All right, so for this video, I'm going to go over calculating slope from a graph and also calculating slope from, I think it's going to be 2 points. Yeah, we'll do that. All right, so let's go over calculating slope from a graph. To calculate slope from a graph, what you're going to do is number one, pick 2 points. So you're going to choose 2 points you can read. Two points you can read, or I'm going to say name. All right, I don't want you trying to estimate points, okay? I need you to name them in whole numbers or integers. And then after you choose the 2 points that you can name, you're going to calculate what we call rise over run. Okay, so let's talk about rise over run. A rise can either go up or it can go down. In other words, it can be positive or it can be negative. Your run can run to the left or it can run to the right. In other words, it can be negative or positive as well. Okay. Now, when I pick my 2 points, I usually start from the bottom point, so my rise is always positive. So if I start from the bottom and go to the other one, then I'll always be going up. But let me show you what I mean. So if I ask you to calculate the slope of the line in this graph, I can already tell you it's descending from left to right. So from left to right, this line is going down. So I know the slope is going to be some negative number. Okay, now, if you don't recognize that off the top, don't even worry about it. We just need to pick 2 points to calculate slope. So I'm going to highlight the 2 points. Now, I don't care what 2 points you choose, just choose 2. And that's the point -1, -2, -3, and up 1, 2, 3, 4, 5, -3, 5. And then I'll pick another one. It doesn't matter which one. That's the point -1, 1. So I'm going to calculate rise and run. Now, to calculate rise and run, I need to just pretend like I'm traveling from one destination to another. So I'm going to travel from the red dot to the blue dot. But when I travel, I'm going to stay on what I call the roads or the black lines. So I'm going to travel up 1 unit, 2 units or 2 blocks, 3 blocks, 4 blocks. You're going up 4. So because you went up, your rise is positive. So that's +4. Now look at your run. To get to the blue dot, you would need to pretend like these little black lines are roads, guys. You got to stay on the road. Please don't do something crazy like, let me erase something for just a second. Please don't do this. Don't say I'm going to go here and then, don't say I'm going to go here and then go here, because you're going through the white spots. Okay, that means you're knocking over trash cans and running in houses. We can't be doing that. If we pretend like these are roads, okay? Because you got buildings and houses on the sides of the roads or off the road, okay? So again, stay on the little black lines. 1, 2, 3, 4. That's a rise of 4. And you're running. When you run here, you are turning to the left. So turning to the left, and I was trying to color code, but it didn't work out. Turning to the left, you went 2 to the left. Now, if you go left, if you run to the left, it is negative. So if I simplify 4 over -2, I get -2. So the slope of this is -2. All right, now those are not the only 2 points I could have chosen. So I'm going to erase it, and I'm going to show you that you could have chosen something else. Now keep in mind, if you run right, it's positive. If you run left, it's negative. If you rise up, it's positive. If you rise down, it's negative. I'm going to show you just 2 different points. So I'm going to I'll stick with that one, but maybe I'll choose something like this. I'll choose that one. I'm going to calculate the rise. So that's a rise of 1, 2. So in this particular case, my rise is 2. And my run, well, I would still have to run to the left. but I won't have to go left 1. So that's -1. So this 2 over -1 is still -2. And I'm going to show you one other thing, guys. Suppose I go back with this point and then, I don't know, let's try this one. You want, no, I normally go up. My rise, I usually start at the bottom and go up. But you can start at the top point and go down to get from one point to another. So this would be down 1, 2, 3, 4, 5, 6, 7, 8 blocks. Down 8 blocks will be a -8. Because I went down. And then I will have to turn and go right. Right how many? 1, 2, 3, 4. Right 4. So if you go right 4, it's positive. Right is positive, left is negative. Okay? But when I simplify this, I still get -2. So I'm telling you, it doesn't matter what 2 points you choose on the graph. Just choose any 2 points. Calculate rise, then calculate run. Make sure you put rise over run and then simplify it, okay? All right, so let's take a look at B. Taking a look at B, you can choose any 2 points you want. I'm going to choose this point, and I will choose this one. I'll choose those two. And I like to rise or start from the bottom and rise up. So I'm going to start from the red point and go to the blue one. So I'm going to go up 1 unit, 2 units, only 2 units. So this is a rise of 2. And the run, of course, which way am I going? So you have to consider direction. I'm going to the right 1 unit, 2 unit, 3 units, to right 3. So my slope is simply 2/3, and it can't be simplified. That's it. Okay? I know that was a positive because I went to the right. I know that was positive because I went up. You just got to keep this in mind, guys. If you rise up, it's positive. If you rise down, it's negative. If you run to the left, it's negative. If you run to the right, or in other words, you turn right, it's positive. That's going to be very important. Okay, let's take a look at something like C. C, I don't have the points labeled for you, so you got to pick something you can read. Please don't pick something like this because you don't know what that is. It looks like 1 and 1.5, but it may not be, so don't pick it. Pick something with integers, like whole numbers, okay, or whole numbers and their opposites. So I'm going to pick something like this one. I read that. I can read that. That's -5, 2. I just got to find something else I can read. Let's see. Okay. I can read this one. That's ordered pair -1, 1. And it's on the line. As long as you can read the points and they're on the line, choose them. Some of you may have been looking at that one. You can read that. That's 3, 0. Okay, but I'm just going to focus on the red and the black. All right, so I'm going to rise. Here I have a rise of 1. And my run, well, I'm going to the left. So I went up, and now I'm going to the left. 1 unit, 2 units, 3 units, 4 units. I went left 4. So that's -4. So my slope is just -1/4. And you can leave the negative with the 1. You can put the negative with the 1, leave the negative with the 4. Or you can write the negative with the bar. Still the same slope of -1/4, okay? Now I'm going to go back over something quickly. Suppose somebody wanted to focus on the blue dot and the green dot. You could have. And I'm going to go down in this case. So black to green. Black to blue, sorry. Black to blue. So that's down 1, 2. Down 2 is -2. And the run here, I went down, so that's negative. The run, I'm going to the right, so I'm going to the right 1. 2, 3, 4, 5, 6, 7, 8. So I get negative 2 over 8, which still simplifies to negative 1/4. Again, I don't care which 2 points you choose to calculate the slope. Just choose 2 and do rise over run if you're looking at a graph. All right, I want you to pause the video and try D. Find the slope of the line in D, and it's going upward toward the right. So everybody should know that slope is positive. All right, this is what you should have gotten. I can read this point. That's negative 1, negative 2, negative 3, negative 4, and up 1. So that's the point negative 4, 1. I can read it. Like, you don't have to write them, but you just got to be able to read them. And I can also read this point. Now, some of you may have chosen something different. Some of you may have used this one right here, okay? Because you can also read that. But I'm going to use the red and the blue. So that's up 1. So this has a rise of positive 1. And as far as the run is concerned, I'm running to the right 1 unit, 2 units, 3 units, 4 units to get to the blue dot. So running to the right is positive. So the slope is simply 1/4. It's already simplified. Now, if you would have done the purple and the red dot, you would have ended up with 2/8. But 2/8 still simplifies to 1/4. All right, E is a tad bit different. E is a vertical line. A vertical line always has a slope that is undefined. And I will tell you, you can pick any 2 points on this line that you want to. Any 2. Well, I'm going to pick those 2. So watch. This has a rise of 1, 2, 3. But it doesn't run left. It doesn't run left and it doesn't run right. So it doesn't have a run. So when you divide by 0, you get a slope that is undefined because the line doesn't run left. The line doesn't run right. So you don't have a run at all. Your run is it's 0. So when you try to divide a number by 0, you get something that is undefined. It doesn't exist. Okay? Let's take a look at F. Choose any 2 points you want to. I'm going to choose this one. It's negative 1, negative 1. I'm going to choose that one. That's 3, negative 1. And I'm going to calculate rise over run. Well, look at it. To get from, and let me color code. To get from the black dot to the red dot, it doesn't rise at all. But it does run. To get from the black to the red, you got to go to the right. 1, 2, 3, 4. But 0 divided by any number is 0. So the slope here is 0. But you all should know that the slope of a flat line or horizontal line is 0 anyway. Because we went over that with the 4 types of slope. When I gave you in this box in the video yesterday, I gave you the 4 types of slope right here. I said the slope could be positive if it goes upward toward the right. The slope could be negative if it goes downward from left to right. The slope could be 0 if it's a flat line, also called it a horizontal line. That doesn't look too flat. Let me fix it. If it's some flat line or horizontal line, the slope is 0. And then I said the slope could be undefined. The slope is undefined if it's a vertical line, guys. Those are the 4 types of slope I gave you in the video yesterday. I think I gave you an example of this one. Like the floor in the room is flat, so it has a slope of 0. Or the wall in the classroom is straight up and down, so its slope is undefined, okay? And then something else I don't think I mentioned yesterday, slope is just steepness, guys, how steep a line is. If you're looking at a graph, it represents steepness on a graph, okay? Okay, let's go back to this. I want to do some real life problems. So just taking a look at G, I don't know what this graph represents. We don't have a title, but I do know on the y-axis we're talking about water in gallons. And on the x-axis, we're talking about time and hours. So you all know that the y-axis acts as your dependent variable. Your dependent variable depends on your independent variable, okay? So when I get ready to write slope, slope is the change in y over the change in x. So I'm talking about on the dependent variable, since it's y on the top in the numerator, that dependent variable is talking about gallons of water. You can just look on the y-axis and tell what that is. And then the x, on the x-axis, is talking about your time in hours. So it's just talking about hours. So basically, when you find the slope, it's going to be some amount okay, or some number, and that number is going to represent the gallons per hour, guys. Okay, that's what it's going to represent, gallons per hour. Whatever slope you find, it's going to represent the gallons per hour that something is maybe leaking, or the speed of the way something is feeling. I don't know because it's not a title right here, okay? And I copied and pasted this from a book. And that was no title. Maybe I forgot to copy and paste it. I probably forgot to copy and paste it. Sorry. All right, heads up. Pick 2 points you can read on the graph. So I'm going to pick something like this. I know they already have 2 chosen for you. I'm going to choose 550 and I don't know. Anything else you can read. But I want to do blue. That's going to be hard to read. Let's color code and do it purple. Okay, that's 3/100. So now I'm just going to calculate rise over run because it's a graph. That's the easiest thing to do. So now keep in mind these don't count. Don't say, oh, that's a rise of 2. That's not a rise of 2 because the y-axis counts by 25s. 25, 50, 75, 100. So keep in mind it's not a rise of 2. It's actually a rise of 25, 50 because they count by 25s. Now, as far as your x-axis is concerned, they do count by ones. But I'm turning to the left, so I'm going to the left. 1, 2. So the rise is 50, but the run is -2. So the slope is -25, okay? -25 gallons per hour basically means something is losing. Something is losing 25 gallons. I'm going to say losing because I'm not going to put the negative on it if I use the word losing. Something is losing 25 gallons of water per hour. That's what that means. Okay, that's all that means. So your slope is -25, but it's talking about a loss of gallons per, and I don't want to put per if I use the slash. Okay, per hour. And you could tell that it was decreasing because it's going down from left to right. It's decreasing. All right, let's take a look at H. Your family is driving from Cincinnati to St. Louis, and the graph relates your distance from St. Louis, which we're calling Y, distance Y, and it's in the unit miles, and travel time with X, and it's in the unit hours. And we all know that distance depends on time. You can't drive somewhere without time going by, so time is independent. It happens first, that's why it's X. So distance is Y. That's why you see it on the y-axis. And time is x. It's the independent variables on the x-axis. What you want to do is calculate the slope or rate of change. In other words, if it's your father driving, how fast is he driving? What's his average rate of change? Okay, what's his slope? What's his driving speed, basically? because it's miles per hour. So keep in mind, slope is simply also the change in y over the change in x. And y is talking about miles, and x is talking about the unit hours. So when I find that number that represents my slope, it's going to be some amount of miles per hour. So somebody's traveling a certain speed because miles per hour is speed, okay? Keep in mind, I'm getting those units from the y-axis and the x-axis. And make sure you put the y unit on top and the x unit on the bottom, okay? Now, for a graph, I'm going to calculate rise over run. I'm just going to pick 2 points I can read. Now, I'm telling you, you could just pick this point and that one because that's what they have named, but I don't want to because I can name points that are a whole lot closer together than those. So I'm going to name, 2 and 240, and I can also name 4 and 120. So I'm going to look at those two. So now let's check it out and see what these are counted by. That's up 40, another 40, another 40, another 40. So on the y-axis, it's counted by 40s, but on the x-axis, it's counted by 0.51, 1.52, 2.53, 3.54, 4.55, okay? So the x-axis is counted by halves or 0.5s. And the y-axis is counted by 40. So let's go up. So this is up 40, 80, 120. So it has a rise of 120. And the run, of course, I'm running to the left, guys. That's 1. No, that's 0.5. 0.5, 1, 1.52. But it's going left, so it's negative. Okay? So I know you can't go negative 60 miles per hour. That means that this person is decreasing speeds at a rate of 60 miles per hour. That's the only thing that can mean. Okay? So for every hour that goes by, they've decreased their distance by 60 miles. So that's what that means. That's why we get negative 60. For every hour that goes by, the distance, and I'm going to put the total distance, decreases by 60 miles. Okay? That's that. Weird problem. I would have written it a different way. My graph would have went up and not down. But since it's going down, I know it's a negative slope. So it has to mean that for every hour that goes by, that person has decreased the distance from Cincinnati to St. Louis by 60 miles. All right, let's look at I. The graph relates temperature, which we're calling Y, and it's going to be in Fahrenheit. And you can tell on the y-axis you got Fahrenheit, to altitude X, and it's in thousands of feet, okay? So obviously somebody's climbing a mountain. We're looking at altitude change, okay, and temperature. Temperature in relation to the height or altitude, okay? All right, so they already gave you 2 points that you can read, but I don't like that. You could count up, but I don't like either one of those. Let me see if I find something that I can read that I know is exact. Okay, I don't see anything on here that may be exact. 830 looks like it might be exact, but I don't think that's exactly on this. I'm not going to use that. I think it's a little off in the corner. So I'm just going to use the 2 points that they gave me, okay? And this one, since the line is not exact, guys, we're going to omit this problem. This problem would work better with this part. So what I'll do is, when I get ready to cover this part, I'll go back up and use these two ordered pairs using this to calculate the slope, okay, instead of rise over run. Let me see if I'm going to do this today. I don't think I'm going to do this today. I think I'll save it for tomorrow. I know you're taking the I-rated reading, but you all do me a favor. I'm going to upload a short video on calculating slope from 2 points. That's going to cover A through G. And I'm going to go back up and use this in this lesson here, okay? But that's going to be tomorrow. So although we will not have class, can you please watch that video for me? That's all I ask, guys. All right, no homework for tonight. Thank you.